then translate it into English for the chat, and then I can answer from there. I like to put up a slide that says who I am because, like, how else would you know who I am? And as we said earlier, I'm a lecturer in artificial intelligence and in cybersecurity at Macquarie University. But before that, I was the CTO of a couple of startups. You may have heard of a company called Pixie. If any of you run Shopify sites, you might use Pixie to improve your images. And if any of you are involved in call centers, you may be aware of a company called Daisy. There's one mistake on this slide. I actually proposed to my wife after 10 days, and we've been married for 29 years now. My wife pointed out that I clearly forgot her wedding anniversary. Um, and my general background is that I do cross-disciplinary research in all sorts of strange fields. So I've been applying mathematics to endangered languages. I've been composing symphonies about chip manufacture, and I wrote some of the first quantum computing programming languages. So that's me. Let me start with a motivating slide. Why would you be interested in data science here? So this was the slide I used to use last semester to motivate students to pay a lot of attention and to work hard. Uh, this is an advertisement that I saw from Daniel Han, and it just boils down to if you can do these 5 things listed here where my mouse is, the convert NF4, BNB4, 4-bit to Triton, work with QLoRa, remove some graph breaks. They were willing to give you a job straight away just because those 5 skills are in such high demand and were so useful to this company Unsloth. And they were very, very transparent that they were going to have a marking criteria and that if you could do well on these engineering challenges, this would be up to, say, $500,000 US salary per year. And they didn't really care where you lived in the world. They didn't care where you wanted to live. They didn't care what your background was. It didn't matter if you had a degree or didn't have a degree. This was the job offer they were advertising. Now, as I said, that's what I used to give last semester. Things have changed in the last 6 months, and so now I point people to this, that Mark Zuckerberg was advertising jobs up to $100 million. And again, he didn't care what your background was, what your degree was in, or anything else like that. He just wanted those skills. Again, wouldn't matter where you wanted to live, but I suspect if you're getting $100 million a year salary, it's very easy to live wherever you want to live. So what is this data science that we're doing? Broadly speaking, we're taking commercial data and applying the scientific method to it, which is a very vague kind of thing. But what does that actually mean? And why is it a separate job? And why are the salaries so high? Let me give you a little next slide. My aunt is a very famous biostatistician and doctor. So she ran a lot of medical trials. There are some drugs like the statin drugs that perhaps your parents might have been prescribed for heart disease. That was one of her trials. And one day I asked her, what's the biggest trial you knew about? And she said there was this trial of 50,000 patients with different COVID treatments. And obviously that happened in about 2020 to 2021. And it was enormous. It was the largest medical trial in history, or one of the largest medical trials in history, and was tracking 50,000 patients. Now, 15 years ago, Facebook ran an experiment, and the experiment was that you know how in America they have the big elections like 2008 and 2012 and 2024, where they elect their president and a few other important roles. They also have the every 2 years where they elect, like, it's not as important an election. And so, because it's not a very important election, not many people turn up. So, Facebook ran an experiment to see could they encourage people to vote. And they ran a test with 61 million users. So it was 1,000 times bigger than the medical trial from the COVID study. And the only reason we know about this 61 million user trial is because Facebook wrote about it. A couple of the staff from that project wrote a paper. That paper was published in a journal called Nature. But even that is not particularly large. Right now, if you pop up a Google search, you'll be automatically enrolled in an experiment that Google is running. How do I know that? Because they're constantly running thousands of experiments all the time. Every time somebody wants to roll out a new feature, so if a Google software developer wants to try something out, they will try it out on some tiny percentage of users and then expand from that if it works well, or if it doesn't work well, they won't. So right now, there are probably 1,000 experiments running, probably with close to 100 million, maybe 500 million users in the trial. So it's obviously a very much bigger task. You could potentially analyze 50,000 patients doing statistics by hand, but you could never do that with 61 million, and you couldn't do it with 500 million either. So this different scale means that data scientists need some different skills. But at the same time, the different scale here makes data science skills also very valuable. So if I look at the trial here with the 50,000 patients, the effect of that was probably going to make a few $1,000 worth of difference to the per patient to the medical community. Well, these experiments are often also worth a couple of $100. So a good experiment run by Facebook or Google or one of the other majors could make hundreds of millions of dollars worth of difference. And so, as a single data scientist working on a project which might have a $50 million impact, of course, data scientist salaries are going up very rapidly. And that's kind of what's driving these absurdly high salaries here, except these are also driven by the fact that we can now do data science on predicting next words, which is a different kind of prediction, and off the back of that, build these very, very useful large language models. So, what else do I want to say here? Data scientists have pretty much 5 tools in their toolbox that they regularly use. The first one is unsupervised learning, which is, I'm just pausing with for a moment then. I'm interested in Zenith's question. Is everybody making sense of what I'm saying? Do I need to slow down? Am I okay? Yep. Okay. I've got one person saying, thank you, Nima. We can break the data into groups. We can make a predictive model. We can do statistical tests. We can do a kind of network analysis to understand relationships and flows, or we can do recommendation engines. If you like this, then you'll like that. Now, traditionally, we've seen most data scientists were trained up on supervised machine learning, and then as a little also ran, they might learn about clustering and would learn a lot of statistical tests. What we're seeing lately is everybody wants to be an Instagram influencer. How do you become a good Instagram influencer or a popular one? Well, the best way of doing that is find some other influencers who like you and will promote your work. So, what do you have? You have a network of connected people and who follows who. And the other one that's become very, very popular in the last few years is recommendation engines. How do we make guesses about what somebody would like to buy next, or what they'd like to listen to next, or where they might want to travel to next? Now, the word data scientist covers actually, it gets used in two different ways. The first is you get um, anybody who does anything with data who isn't a biologist, for example, gets given the title data scientist, but that's probably a bit confusing because within that role, within that space of data scientists that you might find in job ads, there's at least four different roles. There's the data analyst role. These are often very entry level. They're about visualizing data and they don't pay amazingly well. Then the next level up is the data scientist who runs the experiments and makes predictive models. And the next level up is the data engineer who automates the training of those models. And then the level above that being the ML engineer, somebody who's training new language and vision models. What I'll do is let's dive into a data analyst. Um, I put a URL here for Australian jobs here. If you're interested in working in Australia, this is probably the best place to look. So let's open that up. And I'll just pull this one out and close these other windows. And so if we have a look at some of these roles here, 90,000 to 110,000 Australian dollars per year is a good salary. It's a very comfortable life in, say, which is this in Melbourne. Let's have a look at what this person is, what skills are they expected to have? Um, Clearly, they need Python programming in AWS, which are things that I know. So they're looking for a data and BI, business intelligence analyst. And the tool they're looking for is not any of the famous ones. It's an open source tool from Google called Looker. And if let's see what requirements they're expected to have. You need SQL, you need some Python programming to to format the data, and some Looker experience. If you also happen to know some of these tools, that's also kind of good. Let's look down at the next one, which is a little bit more junior. And they're probably going to ask for a little bit less. Um, the only tools they're talking about here are IGS. And so they're looking at things like Monday.com and its reporting capability. And if you look at the expecting people to have a degree in business analytics or similar, let's go for another junior one here, and then I'll stop. They're looking for extensive experience with Excel, and you'll see a few things crop up here. Power BI as well, and what else did they mention here? That's about it. Okay, so that's the kind of job level that we see data analysts at. And when I'm asked about what sort of skills do you need, I usually reply a pulse, as in that your heart is beating, and if you put your fingers on your veins, you can feel that your heart is still working. Excel skills are really important. Most people who use a spreadsheet don't really understand VLOOKUP, and very, very few people understand how to do a pivot table. If you know those, you're a lot more experienced than most people at Excel. And if you're also familiar with turning um, Excel formulas that explicitly look up values into things that use ranges and tables, you are the guru of Excel and you're more capable than most. And so some of those job roles there where they're asking for Excel skills, that's the kind of thing that they're looking for. You'll notice that most of them said you should have SQL. Uh, SQL is such a basic skill that if you've got some data, it's almost definitely going to be in a database. It's almost definitely going to be in a relational database that you query using SQL. Uh, so of all the skills, this is the most foundational one. And if you understand how to join tables together, how to filter tables, how to aggregate tables, then you're on a good stretch there. You'll notice that most of them mentioned some kind of business intelligence tool. So one said Looker, the other one, and I think also said Power BI, and then the second one mentioned Power BI as well. Um, Let me talk through a few of these. Power BI is Microsoft's business intelligence tool. It's free on Windows and it's very popular. In fact, I'd say it's probably the most popular tool at the moment. And most people are not really aware that they've paid for licenses in there for Office and that they've got access to Power BI as well. And thus, knowing that there is a business intelligence tool available is often really good for businesses to be able to help them do their data analysis. It used to be that this product, Tableau, was the most famous. I'm going to demonstrate using that because, as you can tell, I'm on a Mac and Power BI doesn't run on macOS. Very, very similar to Power BI. A lot of people like Tableau more than Power BI. I think I agree with them. It's a bit better designed. In Australia, there's another tool called Click, which is very popular. The reason it's very popular is it's very good at working with the importing of data step is excellent. And many banks are very, the word is siloed. Everybody is in their own silo, their own little tower, and they don't talk to anybody else. And Click is very good at handling that data. And then QuickSight from Amazon is very popular among startups. Now, if you're looking to get a data analyst job, you'll need to have at least one of these skills. And if you want to have a good chance to have a lot of opportunities, then make sure you know two of them. If you're going to know two, you probably want to know Power BI and then one other, depending on what sort of market that you're interested in going for. If you're interested in startups, explore QuickSight. If you're interested in banking, look at Click. Otherwise, use the free evaluation period for Tableau to build your skills up there. If you are a student at a university, then you can get Tableau for free as well. Put those together and you should be able to have a nice portfolio of interesting visualizations. And that's a very strong resume for a data analyst job. And many of these data analyst jobs can be done remotely so that you can work from Nepal for Australian or American or British companies, and they will pay obviously very, very well um, for for these data analyst visualizations. So what I was thinking of doing, and I've only got this half planned out, is I thought I'll demonstrate how Tableau works and what it does, so you can get a sense of what a data analyst might do. And I thought, I know what I'll do. I have this lovely database from a company called TV Maze, which I'll just click on TV Maze, who have basically every television show around the world um, in this one giant database. So if I pick this television show here and just looking at 53647, whatever it was, um, it's going to let me do this. Um, let's have a look at 53648. This will probably be some other random show from somewhere else. That's a Japanese television show. And what surprised me is I couldn't find any Nepali language shows on TV Maze. Um, I'm really surprised by that, and I'm guessing that means that nobody is creating TV shows in Nepal. That doesn't sound right. Or maybe they're just not getting mentioned on TV Maze, or people aren't, because it's a community contributed thing. So maybe it's perhaps not being populated by someone. Anyway, let's analyze what sort of data a data analyst might do when presented with some TV data. Oops, that was not the right one. That's Tableau is down here. Applications Tableau, Tableau desktop. There we go. Right, well, I'm going to start a new workbook. So I need to connect to some file to get the data initially. And as you can see, Tableau can read automatically from a large number of sources. He says, from a large number of sources. So I've got some files here, or if I say I'm going to connect from some database of some kind, I can go and collect data from Google Analytics or from various databases like Postgres or MySQL, or just looking at some other ones here, accounting systems, from LinkedIn, from Amazon's big data service, and so on. Very large number of options. I'm going to read in a text file. So text file, we are in, excuse me a second, documents, devel, presentations, Sparkup. Okay, let's have a look at this tvmaze.csv file. So it's read this CSV file in. I'm hoping that this is visible. This file that I read in has an identifier number, a show, when it first aired, its details from IMDb, and language. And it's guessed that TV Maze ID is a number. That's why it's come up with a hash there. It's guessed that the name of the show is text, that's ABC there. It's guessed that first airing is a date, which is correct, and that the other things are strings as well, which is also completely correct. Let's just run with this at the moment. I have connected, I've grabbed some data. Now, the next thing I'll do is make a visualization from it. What do I want in this visualization? I was thinking I might do a bar chart of some kind, and it's actually telling me I'll need to have a measure and I'll need to have a dimension. And it will suggest some possibilities here. It's given me no suggestions at all, so that's unhelpful. How about I look at the language? I want the language to be the rows, and how about I have um, the count of the number of shows in each different language? And that wasn't very difficult. I just made a bar chart from the data in this database um, just by dragging and dropping. And that ability to make um, visualizations very, very quickly is really very powerful. It's very useful. And people pay money to have visualizations done. And if you can deliver them at very high speed, obviously that is a very lucrative thing to do. Um, let's do another visualization. I've got this date field. So let's take the date of first airing, and I'll drag that as being the axis along here. And how about I have, again, the count as being the rows. And it's showing me the trend over time as the number of shows is growing. And we'll quickly see that there are some problems with this chart. Um, one of the nice things about these business intelligence tools is that they let you interactively make the chart be right. So the problem here is that there's lots of shows that don't have um, a data first airing. The information just isn't in there. So let's put a filter on this to say the first airing. I want to, um, yeah, I'll say a range of dates. So everything from, I'd like to have the same window all the way through. So I'll say from the first of the first, so let's go from the first of the first, 1923. And I'm going to go to the 31st of December in 2025. So 31st of December 2024 would be better. Because if you notice, there was there was a little tail at the end where it dropped down because, of course, not every show that's going to be made in 2025 exists in the database yet. What else is wrong with this? Um, the count is really meaningless for a while. We can sort of see what looks like an exponential curve. So let's make this be some kind of logarithmic scale. And now it's going to look a little bit better. And it looks more like a kind of straight line. Let's put some analysis on top of this. Just put some analytics here. Let's have a trend line. And, I believe that there's let's have a look at that trend line, double click on that. And I believe there's an exponential trend line, which when I take logs will give me a straight line. And that I can use to say, this is a way that I predict how many TV shows there will be. And you can see it's following that line quite well. And in fact, it's even done some statistical tests. If I move my mouse here, you can see it saying 92% of the changes in the number of TV shows per year can be explained just by the year. And that's very unlikely to be a chance result. So unless something changes, we're going to see more and more TV shows in the future. Okay, let's hold that one. I'm going to create another workbook and I'll just show some other things that a data analyst would be expected to do. Yes, I'm going to continue the trial. Okay, let's connect to some data. I'm going to connect that same CSV file again, but now I'm going to add some more. I'm going to add, there were other capabilities here. Let's have a look at the ratings of shows. And I'm just pausing a second because I'm missing what I was expecting to have here, which is the connection between them. That's better. That's what I was looking for. Oops, TV is rating. There we go. And what did it do? If I look at that connection, Tableau has figured out that the TV Maze ID that was in this file corresponds to a column called TV Maze ID in that column. TV Maze ID equals TV Maze ID. And therefore, that when we extract out, when we ask for a question about a row from the first table, we can go and instantly look it up in the second one. Let's have a look. So a little bit of analysis here is what's the average rating for a TV show? So let's take the rating and let's just put in, instead of the sum of the ratings, I think I'd prefer to have the average rating. So on average, a show is rated 6.8. Now I can group this in some way. And I think I'd like to group it. I haven't checked this one, but I'm just going to give it a try. I'd like to know whether shows that mention Nepal in their I'm just realizing Sparkup is a Nepalese company, isn't it? Like otherwise, if I'm doing supposed to be doing India, I'll do India, but I thought it was Nepal. Is that right?
Yes, yes, it is.
Ew, okay. I
But
was just
but
worried I was
but
saying
we're
something
familiar
silly.
with no, no. But we're
Good,
familiar
good,
with
yeah.
Indian tools.
Yeah. I might go for sort of Hindi shows or something, but let's see if I can find shows that have uh, Nepal mentioned in their description, and if so, do they do better or worse than the ones that don't? So I'm going to need to create a calculated field, and I'll call it mentions Nepal, and let's ask, does the string contain? I think that's contains. Yep, contains. If this string contains that substring. Okay, so let's see if I can get this to work. Contains the string Nepal. Okay, well, actually what I'll do is I'll create another worksheet here and let's throw this in. And let's have a count of them. So count of the number of TV Maze IDs. That did not do what I was expecting it to do. Make a table. Yep, there are some. There are. Should we grab the title of these shows? So show name also on the same table here. There we go. So Kathmandu, Kid Notorious. I have never heard of these shows. The Wizard of Nowhere. Um, let's grab the description as well because that seems kind of relevant. Make this a lot wider so that I can actually read it. Um, oh yeah, I guess, the tracker's diary makes sense. Uh, that's an interesting one. Okay, let's go back to that first worksheet. Now that I know that there are some shows that mention Nepal and some that don't, let's compare them. So columns, and the answer is that shows that mention Nepal have an average rating of 7.2 and that don't have an average rating of 6.8. So there is a difference between the two. But sadly, shows that don't have a description at all also score quite well, nearly as good as those that do have a description and mention Nepal as well. Um, okay, let me just pause for a second. Feel free to ask questions now. It's a good time. Meanwhile, I'm just going to think through what I need to say next. So these visualizations that you can do in uh, Tableau are very similar to the visualizations that you would do in Power BI or other tools. What happens after you've created a visualization is maybe you'll turn that into a one of these here is turn it into to a PowerPoint show. There we go. Yep. Or you might end up creating a dashboard. And so the dashboard would include all our visualizations. So we'll put this and this together in our dashboard. And these dashboards are things that every day the business owner might look at the data um, that's being updated automatically from whatever source it is. And by having a dashboard here that has these useful and easy to read visualizations, um, it's obviously you're doing a valuable job. You're making it much easier to run the business if these things are available. From there, I could, as I said, generate a PowerPoint presentation of all my slides. So let's have all the specific sheets from this workbook. Yes, I want sheet one and sheet two. Export that to a PowerPoint presentation, which I'll just call book two. Go, and that is a very wide image, and I'm not sure why it's had to do that. My guess is it's because of this sheet two being very, very big. So I might cancel it and let's remove sheet two. Going to take a while before we get a response back from that. I'm going to let that run in the background. I can't go forward. I can't cancel. I'm just going to leave it running. Um, it'll be quite slow, I suspect. So the next thing I was going to talk about was having seen how you do these with these visualizations with Power BI or Tableau or other tools. What's happening now is that a lot of the visualizations and data analysis work doesn't need a business intelligence tool anymore. And that's because ChatGPT has a built-in Python interpreter. So let's hop over to here. I'll start with a few basic things. If I say write a program that calculates um, 1, 2, 3, 4 times 5, 7, something like that, it's able to write Python programs. And okay, so run the program to check your answer, and it should have access to go. It did get it right, which is kind of good. Um, I can see the program here having been run. It wrote the program to say calculate the result and then display the result. Now that Python interpreter that ChatGPT can talk to has all sorts of libraries in there, including visualization libraries. So let's give it a file. So I'm going to give it the same file. Oh, I hope I can. It might be a little bit big, but we'll see what happens. Um, see if it'll let me upload a 31 megabyte file. I suspect it might not, in which case I might need to shrink it down a little bit. Let's see if it copes. Mm, seems to be good. Um, so let's ask some basic questions about this data file. How many rows in this data file, and what are the column names? And it'll have no problems doing that. If we actually look at the way it's doing it, do you see it's analyzing? That means it's writing a Python program in the background and then getting the result from that. You can also, there's the code being written there. Uh, if you've done some Python programming, you might be aware of the Pandas library that's very good at reading CSV files. So it's loaded the Pandas library, read the CSV file in, um, asked for the size of that data frame, and then asked for the column names. And then that's what its output has been. So therefore, it was able to tell me that there are 82,000 rows and all these things in it. Now let me pop back to my Tableau because I've already forgotten what I did in my first visualization. That was this one, which was a visualization of a bar chart of the languages. So let's go back to OpenAI. Create a bar chart of the number of shows in each different language. And again, the Python interpreter that it has access to includes the matplotlib library. That was strange. Let's do it again. Create a bar chart of the number of shows in each language. Let's expand that a bit, and it should be showing the same kind of information. So let's see it there. Uh, very, very hard to read. Not sure if I can make it any easier to read by changing the visualization here. Not, it's not a lot better, but you can see that English is the dominant language, and then Japanese, and then Chinese. If we go back to the Tableau version, we can confirm that that's correct, because what we could do is we could sort this column, sort based on a field, based on the count in descending order, and we should get the same result. So English being first, oh, Russian being second, and then Japanese being third, Chinese, Korean, and so on. We can do the same visualization we had here, which is finding the trend line here. So we'll need to be very explicit in how we describe this. So let's minimize that one, minimize that one. I would like a uh, I'd like a plot of the number of shows that first aired in each year. Filter out anything from 2025 and ignore uh, shows that don't specify their first airing date. And if you remember, we needed to make a log plot. Actually, I'll just start off with that visualization, and then I'll make changes to it as we go along. Hopefully hopefully that's working. Would like a plot of the number of shows per year. Ignore shows from 2025. Ignore shows with no initial date, with no first airing date. There we go. There's the plot. So now what I can say to it is, well, that's good, but make the y-axis be log scale, and that should quickly come back with an answer. Then I can ask, I'd like to have the line put on it. So put a trend line on this log scale chart and calculate the p-value, which is the probability of it being true. Uh, calculate the p-value, report on the coefficients. And what this should give me is the same information as I had from Tableau. It should hopefully even give exactly the same numbers. Let's see what it comes up with. Not exactly the same numbers. Not sure why. Perhaps because I've included 1922 when I didn't before, but very, very similar numbers. One of the nice things we can do with that is it's a bit easier to make projections here than it was in Tableau. So how many shows would you expect there to be that first air in 2030? What about 2040? And then for something fun, when would you expect there to be more TV shows than there are human beings in the world? As you can see, working with ChatGPT is very, very tedious because about half the time it just fails. Unfortunately, it's now decided to have a long think about it. Writing some code to try and estimate this calculation. And it's given me some wonderful answers here that by the year 2180 or perhaps the year 2154, that there will be more TV shows than there are human beings, which is not impossible. In fact, I'm surprised it would be that late because, of course, it'll be very easy to create a TV show yourself just using video creation in ChatGPT or VO3 from Google in the near future. I think there was one more example I'd done if this has decided to, yes, come back. Yep. And that was I was going to export this as a PowerPoint. So specific sheets, just sheet one, export that, and it should create a PowerPoint slide, but PowerPoint deck. So if I go downloads, there you can see it's created it. So it's got a presentation already created for me. And sort of unreliably, we can probably do the same thing here with ChatGPT. If we upload the ratings information as well, so that's TV Maze rating. I should be able to ask it a question like, do the TV shows that mention Nepal in their description have better ratings than those without? One additional capability you have here is do a statistical test on this to see if it is a chance result. And I couldn't easily do that in Tableau because Tableau is a data analysis tool. It's a business intelligence tool, not a data science tool. And a data science tool tends to be the ones that can give you these kinds of run a statistical test kind of outputs. So let's run that. While it's doing that, um, for these previous analyses, we can actually look at how it was doing it because there should be, like here's the thought one or here is the code that it actually wrote. And so we can evaluate whether it's doing the right thing. And in that sense, it's a bit better than using a business intelligence tool because the business intelligence tool, you just have to hope there's no bugs in it. Whereas here, you can at least look at the Python code and make sense of it. Right, and the answer was 7.2, 6.8 with a very significant p-value. So it's almost definitely the case that shows about Nepal are more interesting than shows about the rest of the world. It's probably the fun thing for the evening. Now, that's what a data analyst does. Let's go back a few screens and ask a different question. What does a data scientist do? Now, data science jobs are much rarer than data analyst jobs. The normal way that you get a data science job is that you get a data analyst job first, and then you do amazing things with um, the visualizations, and you then throw in some little bit of data science sort of work in there. And eventually, if you do that fairly regularly, the data science team might adopt you into their universe. Now, data scientists generally do things in Python. I'm going to show one of the more recent tools that can do data science very interactively. And apart from just knowing Python, it's normal to know scikit-learn. And then depending on the kinds of models you create, you might need to know TensorFlow or PyTorch. You definitely need to know Pandas. You definitely need to know SQL, and you'll need to know how to visualize things as well. Most data scientists have some knowledge of a particular industry. So a data scientist might specialize in finance. or they might specialize in marketing data, or they might specialize in health. Let's have a look at a few job roles here and just get a sense of, again, how much are these jobs worth? Now, that first one is interesting because it's saying it's a combination of data scientist and business intelligence engineer. So it's a very unusual combination. Let's have a look at what it's asking here. Um, they're expecting you know about Azure, which is Microsoft's platform, a lot of Python. They're asking for SQL, and they're very interested in Power BI skills. And notice understanding of insurance and banking. That's a very strange job ad. That's not one I was expecting to see. Okay, now here's an engineer, a data scientist that's a bit more traditional, and the skill that they're expected to know is personalization. Um, and it's actually working for this company themselves, Seek. What are you required to know? Would you believe Pandas, scikit-learn, TensorFlow, and PyTorch? Standard kind of things expected. They're also kind of expecting that you've done a lot of university qualification in order to be there. Let's look at the third one. So this is, again, industry specialization, probably in insurance, and they're expecting that you know Python and surprisingly little else, actually. Um, and you'll notice at this level of seniority, they're not mentioning the salaries very much. The salaries are much more negotiable. They will pay whatever is required in order to get the right person. That first job is very strange. My guess is that that would be about 180,000 Australian. This one, I think they were looking for that's Seek, so they'll pay quite well. That would probably be 170. And this one, because it's in Adelaide, which is not as big a city, probably about $140,000 per year. As you can see, there occasionally there are some ones listed here. That is a very, very unusual job ad to include a salary range and for it to be that high. But also, it appears that the job is betting on horses. So who knows whether that's actually a worthwhile thing to do or not. Um, Remote candidates based in Australia or internationally are encouraged to apply. So they're interested in your skills, regardless of where you are. And I get the feeling that for 300,000 Australian dollars, working from Nepal would be a very, very nice job to have. So, what does a data scientist do? So, taking that same kind of data, what would we do with it? So, there's two kinds of data science projects that happen. One of them is where we want to make predictions, and the other one is where we want to explain, we want to understand what's going on with something. And so, the first question is like, what are we going to do with that? I'm going to try a couple of demonstrations here. I'm not sure these are going to work. I was exploring before the call started and I haven't fully tested everything. So I'm going to make a few mistakes and we'll see how it goes. Now, Orange is a very fun data science platform where you can just drag and drop the data you want to work with. So I'm going to say I need a CSV file import from, I'll say TV Maze. And it's just read that file in and it's identified what's in it. Now, I want to be able to visualize this and see it, so I would drag it a data table. That would let me look at the table, then look at the data, and so I can see here's the first one is kitchen casino, I think it is. And that's its ID number, and it's a show in English. Let's have a little think about what I want to do here. Um, I'd like to find I think I need to have the ratings information as well. I think that would be helpful. So I'll rename this one. Rename. Not having much luck renaming today. No, I don't know why it's not letting me rename, but anyway, I'll just add this one and say that I would like to have the ratings information. That is That's looking good. Just make sure the columns are correct. Column 2, I'll say that it's numeric. And the weight, also numeric. That should work. Um, I can do visualization from here in Orange. So, for example, I could visualize the distribution of ratings. Um, that's very, very wide bin width. Let's shrink that down to something a little bit smaller. Um, DMA's ID, and I am wanting to see the rating. There we go. That's better. And you can see that like it's quite common to be around 7.4, and occasionally you get a show up in the tens or something like that. Let's try and predict some factors from this. So I think an interesting thing to predict is what goes into making a show have a really high rating. So I need to do some data engineering here. I'll need to put in some kind of formula to add a new field, which is the whether or not it's a high rated score, high rated show. Now I'm just going to pause for a second while I remember how to do this, which is I need to uh, preprocess. I'm sure I'm getting this wrong. No, it is a formula that I'm wanting to have here. So I'll just remove that one. Remove and a formula. There we go. So connect it up, and my formula is a new uh, categorical variable. And the expression is if the rating is greater than 9, then we'll call that great. Okay, and send. And if I've got that right, then I should be able to look at my data table and it should have this extra column now. So data table, add a column, and I have when recorded, TV Maze ID, rating, weight, and whether it's great or not. I have a problem in that if there was no rating, I don't know whether it's a great show or not. So I need to do something first, which is I need to filter it out. So let's select the rows. How do I select the rows? I need to make sure, oops, let's, just for my own sanity, I'm going to rename that. It's letting me do it now to being ratings. Select what rows do I want to do with that. I want the ones where the rating is not is defined. Let's keep that. And now if I now join that up with my formula and have a look at the data table, let's have a look. Yes, I have a rating on everything. My great is not defined, so there's something wrong with my formula for great. Let's have a look at that as to why I've got a problem here. I'll just delete that and try again. Create a new, I'll say numeric, but that doesn't seem right either. Rating greater than 9. Let's see if that happens to work. Yep, that's looking good. Great is 0, and we should find a few ones eventually. I think I just saw one go past. Just confirm that there are some that are that good. I'm sure there are because I've seen a couple of TV shows that are very good. Let's do a visualization of the distribution of rate or not. Yes, there are. They're very rare, but they do exist. So 323 of them. What do I want to do with this? I want to take the greatness and somehow predict it. How do I make an amazing TV show? Let's move this down here, move this down here. I need to know what factors are going to go into it. Now, I also need to get my input from here, from the ratings, and join it up with the CSV file. So I need to merge the domains here. So it's a transform, merge data, the output from this formula, and the input from this data table. And let's see if it can merge. Find matching pairs of rows where the TV maze ID matches the TV maze ID. Excellent. I will have a look at I'll just change this data table to be from this one instead. Moving. And change the data pipeline here to being data to data. Get rid of that. Let's try that. Try that again. Merge the data into the data table. It is data to data. Good. And there is no data whatsoever. So there's something wrong with my merge happening here. Find matching pairs of rows where the TV maze ID matches the TV maze ID. That should be correct. I'm just pausing on this for a moment to try and figure out what I'm doing wrong. The point of the exercise that I'm doing here is to demonstrate this is the kind of thing that a data scientist would do. Create new features in the data, extract additional information, merge other data sets in, and having merged the data sets in, we'll then make some sort of predictive model out of it. I'm just going to take one moment to stare at this again to understand what's wrong. And maybe it's because I've got this coming direct. TV maze, some combinations of values and extra data appear in multiple rows. Okay, and so I think it's telling me that it's not happy. So I'll need to make a uniqueness to simplify this data. This is, again, very typical of the workflow that a data scientist has to do, which is to realize what you're doing doesn't make sense or can't be done or has errors in it. So I would like to be unique, group by TV maze ID. When we see the TV maze ID, take the first one, and let's use that as our input data instead. Not sure if you saw, but that actually finally succeeded. Let me clean this picture up so that it's a little bit easier to see. We have the ratings, we have the TV shows, From the ratings, we selected the rows where there was an actual rating there. Then we took the data that matched that and we added a formula for greatness. Then we extracted out to get just the unique ones there, which we then matched up with the TV show. And the result of that was some data. So that's our data engineering pipeline. Along the way, we can have a look at the visualizations. Having got this data out here, I now want to make a predictive model from it. So I'm going to use um, let's say, logistic regression. And I'm not sure if I've got any data in here that will actually predict it, but let's just see what comes out of it. The logistic regression is trying to predict, um, it's got some problems here, probably not enough fields for it to do a reasonable job of it. And so thus I'm not seeing anything here. Let me think about this for a second as to why it's saying that. There's no target variable. So I need to select columns. Of course, select columns. But from the merged data, I want to say that great is the thing we're trying to predict. And the features that you can predict it from, I'm sorry, the target is great. And we can predict greatness from the first airing, and I'll need to put some more stuff in here about like that you can use it to predict it from. But let's just see if we can predict from the first airing. Is it possible to predict whether something is great or not? I suspect the answer is it's going to be terrible, but let's see how that logistic regression goes. The error is the error at the moment is it expected a categorical class variable, so I'm going to need to transform it into a categorical class variable. Or if I pop back to my formula, if I made it this into a categorical, it might work. Let's see if I can make this happen. Uh, rate is rating greater than 9. I'm sure that's what I had before, but we'll just remove it and see what happens. And as you can see, that flowed through the pipeline. It's rate has not worked here. I'm probably not going to successfully fix this pipeline. But the point of what's going on here is this is what a data scientist would be doing, coming up with a model so that you can predict. And then off the back of that model, we would then score it to determine how good a model it is. Now, at the moment, that's just going to give me an error. There's going to be no interesting scores there. To be able to report back, this is what matters. This is what uh, these are the factors that lead to great TV shows, which, and then how good a model is that? How well does that correctly predict greatness? And I'm just going to have one last stare at this. Give me 1 minute more, and data has no target variable. Data contains a single target value, which is obviously something wrong with my formula here, and I'm not quite sure why my formula is failing here. Values true, false. Let's see if that happens. Yep. Oh, I think I've finally managed to get it to work. And how good a model is this? Um, Still not coming through. Not sure what I've done wrong here. Um, this is the kind of pipeline that a data scientist would make. It's rare to see people using Orange for this. I'm using this as more of a demonstration so that you can see all that's possible very quickly. But we are seeing this happen more commonly. We are seeing more job roles use data science workflow pipelines rather than programming everything yourself. And that's very interesting because that will make it easier for more people to get into data science and do data science, which is the more people are in, the more interesting analysis will be possible and the more valuable our work will be. Popping back to the presentation, haven't quite finished the story because we could do the same thing with ChatGPT. So this already had the ratings information and the TV maze. So what I could do is um, introduce a new, just wait for ChatGPT to catch up with me, introduce a new column called Great, which is true um, if the average rating is above 9.0. Then create a logistic regression trying to predict rate based on the date of first airing. Report on how successful it is. And that should be able to perform everything that I was doing in Orange, including including fixing up the error that I was making. And here, um, and it's created a model. It's a terrible model. It always predicts not great. The coefficient being slightly negative, meaning more recent shows are more likely to be terrible, and some very, very small numbers here. The problem being that I haven't got enough feature variables to do something useful. So what I'll do is I'll ask it to um, also include into the model a TF-IDF vectorization. So that means use words and phrases from the description um, of the show. Um, report on the most influential words and phrases. And as that churns away, we should be able to get somewhat better results from it. As usual, half of the queries we send to ChatGPT fail. Let's retry. The beach ball continue to run for a few moments. There we go. Let's try again. I'll leave that running because I've only got 5 minutes to finish the presentation. Although it looks like I might need to run it a third time. Let's just see how it goes. Yeah, just do the top most common 1,000 engrams and only engram range equals 1, 1. Well, basically, this is going to tell us what words are the best at predicting whether a show is particularly outstanding. Let's see how it goes. Meanwhile, um, the other job roles we see are data engineering roles. So these are even more high paying than data science roles. So I'll just have a quick show through of these. So as you can see, starting in sort of like the 150,000 Australian dollar range. And what are the tasks that you're doing in this sort of role and what sort of skills are required? Um, and there are a variety of proprietary tools from different vendors for dealing with ETL, extract, transform, and load, and to do the to provide tools for analysis. Um, this is a very strange one. I've not seen this company before. And again, what are they asking for? Tools for extract and transform and load, and setting up pipelines and so on. And lastly, for one of the medical insurers, third example, what are they asking around? Extract, transform, and load tools. Again, AWS, SQL, some level of Python. These are jobs that you're not likely to get without a lot of experience. This is kind of the role that you would get after you've been a data scientist. After you've been a data scientist for a while. If your programming skills are strong, you may be able to get into a data engineering role. They're in a lot of demand though. So these roles are worth getting your skills up to be able to do this. And again, there's a lot of flexibility about where you work from. If you're a strong data engineer and you want to work from Nepal but earn Australian dollar income, usually that's not a big problem. Um, I was going to walk through a typical project, but I'm a little bit short on time. And then one level up from that is machine learning engineer jobs. So this is the people who run the tasks, and I don't even have a few of them here. Let's have a look. Um, that's kind of the role that this sort of person would have. Um, so deep proficiency in PyTorch and TensorFlow in order to create interesting models. These tend to be very rare. And here's an example where it's presumably a defense or public sector job. We might see another one here that's, again, it'll be talking about PyTorch and TensorFlow and extreme levels of skill like that. Um, Wrapping it up, the big elephant in the room is, will there be any junior roles left, or will AI take them all? Um, One thing you might have noticed is it requires a lot of skill um, and understanding what you're actually trying to achieve. If you look through the prompts that I've had to give in this particular session, they're not simple. They're quite sophisticated statements that we're making, and they're using a rich vocabulary that you really need to be trained in data science in order to understand. So we're not seeing, let's let it run. We're not seeing junior data scientists suddenly out of a job. What we're seeing is it still requires a certain amount of skill, even to prompt ChatGPT correctly. Now, having got that skill, you're then much more productive. Well, hopefully. I mean, what you've seen is it would take me sort of 15 to 20 minutes to demonstrate something using a tool like Tableau or Orange. And then when things were working, we'd get sort of about 5 minutes to get ChatGPT to give the answer. And so here it's coming up with some possibilities here. Well, it's still thinking about that, so I'll carry on. Um, Regardless of whether the tools make it faster or easier, responsibility is still a thing. Making sure that the visualization happens, making sure the dashboard is created, uh, reprompting ChatGPT when it does something stupid, that's still a part of the story, and it's still a job role that will exist. Also, because there are so many white collar jobs that are going to be replaced by AI over the next few years, we'll need to test whether or not prompt changes making a difference to how the AI functions. So expect a lot of jobs around that space of let's retry ChatGPT and see if it gives the same answers with this different prompt versus something else. And again, that's very much the role of a junior data scientist to make sure those sorts of experiments run. So, in summary, uh, the kinds of roles that we'll see, there'll continue to be data analyst roles, but they will change. Uh, your use of ChatGPT will probably make you much more productive, but how you get the job there and the kinds of jobs that you get hasn't really changed much. And then for those of you that have got some data analysis experience or are just that little bit more experienced, data scientist roles are also still happening. And there's still a need to manage experiments and make sure that everything is running. So, on that note, let's just see what the true factor is of how to get a fabulous TV show. And the answer is it should talk about planet, Svengoolie, Downton, obviously Downton Abbey, um, or a couple other phrases like that. And these things generally are less interesting. And over time, TV shows have been getting worse. So let me conclude by saying that instead of watching TV, maybe practice up your data science skills and uh, your future will be bright. Thanks.
All right. Thank you, Dr. Baker. Anyone from the audience, if you guys have any question, please feel free to ask in chat or just raise your hand and we'll give the mic to you. So we have around 5 minutes for this.
Okay, Gahana's question. Are there any emerging industries where business analytics will play a critical role in the future? Um, I will say almost every industry um, is going to be using business analytics. What we've seen over the last couple of years is a process called digitalization, which means try to make sure we capture data about every step in every process in business. And now that that data is being captured, we're seeing companies get very efficient because they look at the analysis of that digitalization. So the answer is all of them. Every industry is becoming more analytic based, and every industry is caring more about efficiencies and numbers and hiring data analysts in order to uh, perform that analysis and understand it. Um, yep. As a high school student, what things should I do or get started on so to gain advantage in the future? I intend to get in data science and ML. Thank you, Anshudeep. Um, Mathematics is the most important. Uh, Make sure you understand things like, I'm not sure where you were in high school, whether you've done calculus yet or not. Make sure you understand how derivatives work. Make sure you understand how integration works. Make sure you understand how probability works. And those kinds of skills will set you up to be able to understand what you're doing in machine learning. If you're more interested in data analytics, um, which is a good starting point as well, then strangely enough, being a good storyteller or being a good artist can help. Uh, Being able to know how do I make, I'll just pop back to one of these, how do I make this picture look better? So when I didn't have it sorted, if I remember where I had my sorting, it looked kind of ugly like this. Why did it look kind of ugly? Well, because we like to have, let's change my sorting again. We like to have it smooth and in proportion. Again, an artist kind of thing. So, English language is important, mathematics is very important, and then maybe storytelling and art. Kirtan's question. I'm just starting out in this domain, and most of it seems like mathematics. So, for somebody like me just starting out into the field, what mathematical concepts to prioritize first? Yeah, so similar to Anshudeep's question, um, probability, uh, calculus, so differentiability. So, how do you differentiate um, um functions? That crops up in a lot of places in data science and making machine learning models. Um, in some schools, in some countries, you also learn matrix arithmetic. If you're, I don't know if that's part of the curriculum in Nepal. If it is, great, understand that. I might just write some of these down in the chat so that's a bit easier. So probability is very important. Calculus, especially taking derivatives, and matrix multiplication. And the area is known as linear algebra. Um, but this is usually taught at university. So don't worry too much about that last one if we just pop those in. I think I was busily typing something there and my chat was disabled. I don't know why. Let's try again. Let's see if I go back into the chat and see if it'll let me type again. It's not, so I'll just leave this for an email afterwards. Oh, we go. Here we go. Send. Um, Prapti, as someone from a non-IT background, is it possible for me to get into data science? I'm a little bit biased here. I'll say definitely yes. In fact, the Masters in Data Science at Macquarie University does not require you to have an IT background. It helps. It definitely does help. Um, but if you don't have that background, you can pick it up. A new question: what exactly do data scientists do? Creating models and doing analysis. Yes, that's pretty much it. The presenting and creating reports, that's more of a data analyst job. So a nuge, that's two jobs there. The first part is data scientist. The second part is more data analyst. It's rare for a data scientist to be doing a report presentation unless it was a report around the model that they had created. Yep. Any other questions? Gahana, we've been listening. Data science are among the most replaceable job by AI. How scared should we be? Um, I think with I think data scientists are not the most replaceable job, but they're the job that's going to see the most change. So as I was sort of describing at the end here, um, you still need somebody to take responsibility for the model to be created. And there's still going to be lots of testing to be done. However, the skills that are useful now are not necessarily the skills that are going to be useful in 3 years' time. Uh, so I don't see a lot of data scientists losing their jobs. Um, in fact, I see that there'll probably be an increase in data science jobs, but they're going to have very different skills. Unfortunately, if you want a data science job now, you need to understand Python and scikit-learn. But in 3 years' time, it'll probably be about how good are you at prompting and how good are you at verifying the results of things. Ritesh's question. Uh, if you were starting a career in data science today, how would you structure your learning path differently from when you started? Okay. Uh, I need to say, Ritesh, I actually started my career building pipe organs. So I was a musical instrument maker was my first job. And I spent many years moving from that into other roles. So I learnt a lot of my data science before the Python programming language existed, and when we had to do everything by writing your own programs. Um, I did have the advantage that I had done a lot of mathematics at university. So that meant that the mathematics was not difficult. And my brother taught me how to program when I was very young. So I was fortunate in having the programming as well. Um, how would I do things differently now? I think I would spend a lot more time with AI and with language models. Um, you can use the free version of ChatGPT. You can use the free versions of Google Gemini. DeepSeek is available as well. You can also use Olama to run things on your own laptop. Uh, any of these will help, can answer questions about data science, can answer questions about how to do data analysis, and also many of them can actually do the data analysis themselves. Putting those together, I think that's what I would focus on now. I would take some data and do some analysis on it, try to make predictive models, ask ChatGPT, how would I do data science on this data set? Actually, let's ask that question. I'm going to start a new chat and I'll upload exactly the same content as before. Only this time I'll just say, what sort of data analysis should I do? So let's give it TV Maze and TV Maze ratings. And I'll just ask it, what would a data scientist do with this sort of data? And let's see if it comes up with the same answer as I would have done. Let's see how it goes. So it analyzes the data to figure out what's in it, and then we should be able to should see what it comes back with. I think this is a pretty good answer. A data scientist would explore the missing values, definitely. Um, understand why rating is missing. They would check for duplicates. Yep. They would try to understand descriptively. They would analyze the ratings over time. Um, in fact, it came up with a very similar question. Um, uh, let me have a look at some other ones here. Um, it we might do a time series analysis. We might try to predict greatness. We might try and find keywords. We could do a survival analysis. How long does a show last before it goes off the air? How quickly does a show become international? Are there any unusual rating changes? And so we could ask it, yes, guide me through um, one of these analyses. This is probably how I would learn data science today, um, differently to how I did it. Any other questions?
I think that's about it, Dr. Greg.
Okay.
All right.
Thanks
So,
very much.
okay, thank you guys for attending this session, and thank you so much, Dr. Greg, for talking and for this lovely presentation. Uh, just a quick thing before we conclude. Uh, if you want to learn more about what Dr. Baker is doing, and if you want to follow him, you can find him on LinkedIn. If that's okay, Dr.
Yep.
Greg.
Yeah. Do. Yeah.
Yeah.
I'll sort of put it up here so that it's easy for people to find me. I have a funny LinkedIn profile, so
Yeah.
that's my name there because there are several Greg Bakers.
Uh-huh. Yeah, and you can follow his blog as well. So the blog's name is Prakti, can you put that up in the chat?
Yep.
Yep,
I
yep.
can't put in the chat because the chat's disabled, but
No,
that's
no, we,
the.
we did it. We did it for you.
Oh, okay. Thanks.
All right. Yeah, so thank you, everyone. Uh, that's about it. See you. Thank
Okay.
you, Dr. Greg.
See you all.